Right. Good afternoon. Today we are going to continue the example that we were doing yesterday. Okay, so we're going to do two, okay, 3D mold circle example, and then we're going to go into design analysis of beam under combined loading. Again, this also involves 3D mold circle. Okay, right. So if we look at the problem we had yesterday, we were given the stress state, okay, and we have to determine stress Y value. The maximum shear stress allowable is 73 megapascal. So we discovered that one value that we found where stress 1 is at 160 megapascal, this value is impossible. Okay, impossible as in it's not a right value. Is because of what? Because part of the 3D mold circle is outside the what? Point of no return, yes or no, right? Point of no return, i.e. the red box that you can see over here. Okay, so you can see this box that I'm highlighting, right? So if we were to choose the value of 160 megapascal, it's outside the box. And then when we construct 3D mold circle, part of the 3D mold circle is also outside the box. So this is not a valid answer. Then we go for the next solution, right? The next one. So what's the difference between the previous one? Remember, the stress average can either be on the left-hand side, which I'm highlighting now in yellow, right? And we realize that it's outside the box. How about the stress average now is on the right-hand side of point X, okay? So this is where we constructed this value over here, or this diagram where the mole circle or the stress average is on the right-hand side. And we realize that stress Y2 is at what? 60 megapascal. Then in order to certify that this value is fine, you have to construct what? 3D mole circle. And you have to ensure that all the 3D mole circle are all inside what? Inside this box over here. Okay. And it is, right? We started sketching 3 circles. All the circles are all inside the box. It happened to what? Work out. Okay. So we have partly solved this problem, but we're not done yet. Okay. So let me copy and paste the question again. Right. So it's a continuation. So we found that stress Y1 is equal to 60 megapascal, and this is the valid one. Okay. So this question wants us to find how many values? 2 values. Okay. So we are short of one more value. So the next value, we somehow have to like figure out what are the other possibility. Okay. So the other possibility is we are going to use the value of, before I go on, okay, so we are going to determine the second stress Y value. Okay. So another possibility is we are going to use the criteria where stress mean is equal to twice of 73. Okay, so it's 2 times, or I'm going to put a negative sign over here, minus 146 megapascal. Okay, we're going to use this condition now. Okay. Some of you might be asking, why are you doing that for? Okay, I will explain later after we have completed drawing the 3D mold circle. Okay. Right, so we are going to construct 3D mold circle, and I'm going to just focus on the negative, okay, of the 3D mold circle. So we have 146, so we cannot go beyond 146, so I'm going to go minus 160, 140, come on Eugene, 140, not 14. 120, then you have minus 100, 80, 60, 40, 20, 0, 20, 40, 60, 80. Okay. So make sure that the interval are the same. Okay. And then we have our shear. So again, we have 30, 40, 60, 80, 100. Shear stress clockwise. Minus 20, minus 40, minus 60, minus 80, minus 100. Going anti-clockwise. Okay, and I'm going to sketch the box where our limits is. Okay, so the box is 146 and 73. Is 73, 146. This is just an eyeball. 73. So 146. So 80, 80, 100, 120, 140, 140. Okay, somewhere around here. Okay, so it's 73. Okay, so this is about my 73. Okay. So what is still a constant is our normal stress of 40 of minus 50. And then we have minus, we have positive 48, but we know in shear, positive shear don't mean anything on mold circle. It all dependent on the rotation of the element. Okay, so 48. Okay. And we are aware that point X is at the bottom. Okay. So we are going to try. Okay. We know that point X is there, and we know that this is our point Z, right? We are very, very sure. So we are going to use the stress mean value that is equal to what? Minus 146. Okay. So what we are going to do now is the 146 and point X will be one mole circle. Okay. So I'm going to draw a line connecting from here to here. Okay. So with this, we have to determine point Y. Okay. So how about do we do that? Okay. And I've taught you the basics before. Is we are going to apply the rules of a circle. Okay. You can don't apply the rules of the circle. If you don't apply the rules of the circle, what will happen is you are going to formulate equations like this. Okay. I repeat again, if you don't use the rules of the circle, you're going to formulate a set of equations like this. Okay. So what do you prefer? Rules of the circle, yes or no? Looking at equations like this take too long to what? Figure out. In fact, these equations down here, they also use what? Rules of the circle. Why not just construct it using Mohs circle? Yes or no? Okay. So rules of the circle, what did it say? So if we were to go back, not too far back, we did Mohs circle, right? When we started Mohs circle, did we do rules of the circle? I can't remember now. Where is rules of the circle? Is it week 11? Any idea when did we do rules of the circle? Anyone? I can't remember now. It's not here. Is it here? Yeah. Can you remember this? Right? Rules of the circle. Yes or no? Okay. I'm going to copy this. It's on week 11 Wednesday, and this is week 12. Exactly a week. Okay. So this is the rules of the circle. Right? And now, come on, allow me to rotate. Can I rotate? Can I rotate? If I were to rotate this by I'm going to flip vertical, right? I mean, it's not perfect, and I'm going to rotate stupid software. Only two direction. Okay, this is very bad. Right. So I want you to visualize this, okay? Can you imagine if this point is here, right? And then this point over here is here, right? So what we can do is, all we need to do is take this line. Okay, I'm going to copy and I'm going to paste. And I'm going to take this line and we're going to rotate 90 degrees. When that's the case, this angle is how many degrees, anyone? 90 degrees, like over here, yes or no? Right, if you zoom in close enough, that angle is how many degrees? 90 degrees, rules of the circle, right? So when that's the case, you can more or less, so I'm going to call this point over here. This is our stress A. This point over here, this is our what? Stress B, right? And ultimately, we will realize that this point over here will be our stress C. Later on, you will see it. Okay. So now we can now determine the position of stress B. Yes or no? Right? We are going to determine, we're going to determine the position of stress B and find stress Y in the XY plane. Okay, so we're going to find stress B, stress Y2 in the XY plane, and we will later construct, or we check if this is a valid answer. Okay. So to determine stress B, I need to find this angle over here, which is my beta angle. And that beta angle over here is the same as the beta angle over here. Now, we are not doing the 2 theta thing. Okay, this is not 2 theta, because 2 theta, we get it from the center of the circle. This is not the center of the what? Of the circle. Okay, so now we can determine that tangent beta will be equal to what? Will be equal to 48 over 146. Why is it 146? It's because it's 73 times 2. So 73 times 2 is 146. And minus by the monomer stress of 50. Okay. So beta is equal to 146 minus 50. 48 minus 96 inverse tangent is equal to 26.6 degrees. Let me do it again, okay? So 48, I got it right. So 146 minus 50. So 48 divided by 96, inverse tangent is equal to 26.56 degrees. So from here, we can find our stress B. Okay? So stress B is equal to minus 50 plus. So I do some, so it's equal to what? 48 tangent 26.6. Why is that? Because if we were to look at this triangle over here, right? This is beta. And if this is our x and this is our y, so tangent beta is equal to x over y. So x is equal to y tangent what? Beta. Okay, which is what we have here. So this is equal to minus 50 plus by tangent 26.6 times by 48 is equal to tangent 26.6 times by 48 is about 24.037. Okay.